New York City's skyline is iconic, but for building owners, it represents a changing landscape of regulations, rising costs, and urgent carbon mandates. The pressure is on to reduce energy use and emissions without bankrupting the budget or disrupting the lives of tenants.
Over the past few years, specifically the last 3 years, our utility costs kept growing because the price of steam and the price of electricity increased every year by at least 10%. And that meant that the single most impactful part of our budget that the board could actually impact was utilities. And that's why we looked at solutions that would mitigate our energy consumption and allow us to stop that inflation. Enter Local Law 97. Now we have a reason to do this now rather than wait for later. That's one of the tendencies of a lot of boards. Difficult decisions can be postponed. You have a tendency to procrastinate. But now, because of Local Law 97, we actually have urgency, and we needed to start planning for 2030 today. And that's one of those things that drove us to be the first to try this on a large residential building in New York City. We've been making improvements to the building for the past 7 years, including changing windows, changing all the lighting to make it energy efficient. We've replaced the fans that actually provide ventilation to the building a few years ago. The problem is that these are all relatively minor adjustments that all proved moot points and that did not really change the overall budget and the overall consumption of utilities. So we had to look for something more important.
150 West End Avenue is the quintessential early 1960s New York City high-rise. It incorporated all the things they learned up to that point, including central heating and cooling, larger windows. Well, the central ventilation systems were built to be oversized to begin with. They were also built of masonry, which wasn't very tight, if you will. It's like trying to drink from a cracked drinking straw. And so because of the leaks, they had to put bigger fans on the roof and exhaust so much more air just to serve the kitchens and bathrooms systems designed to serve. As a result, more than 50% of the air being exhausted from the building was wasted. It wasn't serving the apartments at all. And all that air was taking all that energy with it.
The higher floors got a lot more exhaust than the lower floors. So the whole building, the positive and negative airflow, it was all out of whack, out of balance.
There was little that could be done to address the energy waste of the ventilation system if the leakage wasn't solved. The fans were replaced, but when turned down to reduce the energy use, the system stopped working properly, requiring that the fans be sped up again. It didn't make a dent in the steam usage and utility costs because they were only treating a symptom, not fixing the real problem, which was the leakage.
Stephen Winter Associates works on consulting for accessibility, energy efficiency, decarbonization, and health. We work with policymakers, program implementers, and with private developers and owners to make sure that their buildings are performing as best as possible. On this particular project, we were brought in to be a third-party technical reviewer. There were already other sets of eyes on the project because Con Edison is involved, and there was measurement and verification scope. We came in to be a third-party review of the entire scope and the analysis. So the challenge that we see in almost every multifamily building, to be honest, is that the ventilation system just doesn't work. And so we had an opportunity here to save money and improve indoor air quality at the same time.
There are a lot of initiatives that we've taken under consideration. Electrification is a very common initiative that's brought up, but these are all huge projects. They're enormously expensive and disruptive. They require major infrastructural work, and we were quite hesitant to undertake something that significant without the proper funding and without confidence in the results that we'd see.
The Aeroseal process is unique. It is really the only way I've found in over 20 years trying to fix these that gets you all the way to the finish line. You certainly couldn't go into an occupied building like this and start knocking down walls left and right to try to rebuild these things.
I was a little worried about Aeroseal repairing the ducts, and I was worried about scheduling, getting into the apartments. How is this gonna all come together? Gaining access to all residents' apartments gave me some anxiety.
Aeroseal works by sealing the ducts from the inside. We don't have to tear the walls down to get to them. We actually just block off all of the intentional openings, and then we can pressurize the duct, send our sealant down into the duct, and it finds every gap, crack, and hole and seals them with a non-toxic sealant that ensures that I can eliminate all of the waste and all of the leakage and get it down to where I can truly balance the systems for the most efficient operating system that you can make.
Aeroseal came in and was able to seal the ductwork from the inside, install balancing dampers, which allowed the same airflow from each apartment, and then was able to adjust the fans so that they used as little energy as possible with still getting consistent airflow to all of the apartments. So this improved indoor air quality while reducing energy use at the same time.
When you think about most of the solutions out there, they require several months, if not years, of work. They're disruptive, they require destruction and major infrastructural work. Aeroseal promised to do this in 3 months, which actually was delivered, and that was so much less than everything else. A non-invasive, relatively quick, non-disruptive solution was something that was obviously very attractive to us.
On the first day of sealing the riser, it was incredible. I witnessed the manpower and the organization and everything that went into it, all the details that correlated into making this technology work. So I would say it went a lot smoother than when I first heard about it.
By sealing the leaks and balancing the flows, the project cut the building exhaust by 75% without sacrificing the ventilation performance. That reduction saved steam use, as well as cutting the electric use for the fans and for the central chillers that are used to cool the building in the summer. This resulted in over $241,000 of total annual utility bill savings while avoiding 208 tons of CO2 equivalent in steam usage within the first 4 months, all with a less than 4-year payback period before incentives.
Throughout the process, Stephen Winter Associates was observing what was happening on site and then reviewing the data analysis that was done. Before the Aeroseal was completed, we looked at the utility bills monthly, and then after completion, we've looked at, I believe, 3 months of data so far. And there was an analysis done by the Aeroseal team, and Stephen Winter Associates was able to review that analysis, dig into the details, and confirm that the energy savings that Aeroseal was stating made sense from a technical perspective.
So we were very excited about the results we were able to achieve with this project. We've reduced their steam use by 30%. And even when the cost of the steam has gone up 40% in the last 2 years, they're pretty much heating the building this year for the same cost they did 2 years ago. So it's a huge hedge on inflation. This also is a huge decarbonization opportunity. We're eliminating many, many tons of carbon from being released into the atmosphere, which is a really big deal in terms of being able to try to control climate change. And so that's a really big win for us. It's a big win for the building. It's a big win for the planet too.
In New York City, large buildings are subject to Local Law 97, which is a limit on how much carbon they can emit. And every time we're consuming energy for heating, for cooling, for hot water when we take a shower, all of that is contributing to these carbon emissions. And so buildings are subject to these limits, and over time these limits are going to ratchet down. So anytime we can reduce energy use, for example, steam, gas use in the building, that reduces our exposure to penalties.
When we saw the results, it was immediately a sense of relief because we had done so much work to push this across, and it was great to see that we were actually seeing material savings in our energy bills.
My goal is to get the building as energy efficient as I can, and this was a great step towards reaching that goal.
For a fully occupied co-op, that balance of financial discipline and limited disruption was essential. It's what allowed us to move forward.
Ventilation optimization isn't just a repair. It's one of the most cost-effective, least disruptive ways to reduce utility costs and carbon emissions.